That's because I like to code more than I like presentations. But I like to tell you it anyway. So this is me. I'm the lead dev for Vonk. So if you have any questions, I should be able to answer them, as long as it's about Vonk. So what we're going to do is a couple of prerequisites to do Facades with Vonk. I'll tell you what it is, a bit about ASP.NET Core and about the Vonk architecture, and then building a facade. And of course the exercise in the next session. So when you're bored, I don't mind. But then you can already download some of the prerequisites. There's a link here which has all the other links to the downloads, and it also has the exercise. It even has the exercise on the plugins on my previous session. So what you would need is, of course, you need .NET Core, because Vonk is a .NET server. And either Visual Studio, I recommend that, or if you don't have that, Visual Studio Code. Something to do REST requests. You can download Vonk 3.1.0 from FHIR, including an evaluation license. And you can clone Vonk Facade Starter from GitHub. The exact links are all in the bit.ly link. First, what is Vonk? Who here has already seen Vonk before? Okay, then I will still explain for those who haven't. Vonk is a full-fledged FHIR server, implementing all the FHIR RESTful operations, search, and the whole CRUD, conditional, transactions, whatever. And it can act as a clinical data repository, so have all your resources in native FHIR, including all the search facilities, and it can also be used as the platform for, as the backend for your apps, because you can then natively make your apps talk the FHIR RESTful API to the data, which is a very well-defined and described API, which saves you from defining and describing one of your own. And it saves the maker of the app reading another. It has multiple storage implementations. You can run it on SQLite, you can run it on SQL Server, including Azure SQL Database, and on MongoDB. You can even run it in memory, but that's more useful for unit testing. Then there is, of course, a facade. That's what this whole session is about. There's a plugin framework, so if you want to make custom operations, make custom logging, whatever, you can do that as well and plug it into the server. It runs on .NET Core and is therefore cross-platform, so you can run it on any operating system, including Docker, Kubernetes, etc. It's a reference implementation of .NET versus the one in Java. And because we started this by the original background of this goes way back to our open source server Spark in 2012 or something. Now, what is a facade? I said a FHIR server is an implementation of the FHIR RESTful API, which I hope you already know. You can have a full FHIR server to implement that, but you could also apply that to a system you already own. So if you have that system already here with all these tables that you are very familiar with, and then you put a nice facade on it. This actually sometimes happens in Amsterdam, by the way. If they have a large restructuring in the city, then they put up these cardboards with a nice facade on, so you don't see it. Not all of the houses are facades, by the way. They are real. So how does it work in Vonk? Therefore, you need to know that Vonk is not just a server, it's a FHIR framework. And how can you use it? This way, it takes a request, of course, and it provides a response. This is very similar to the ASP.NET Core framework, and that is not by coincidence. That's the way we designed it. There is no MVC involved. For those who know ASP.NET Core, we don't do MVC. It's a straight pipeline. It goes back and forth, because that's much easier to comprehend. Then, on this pipeline, any one of those components will inspect the request, see, is this my request? Do I know the answer? If I do, I provide the answer, pipeline is cut short and you return it. Now, plugins can be provided as custom pieces here in the pipeline that inspector request may provide a response. But the interesting here is where we do facades, because that was previous session. We have an interface for searching and for writing. It's just two interfaces. Those are implemented by our own storage implementations as well. There's no sideways. We implement these interfaces ourselves. So they are rich enough to provide all the searching and updating. And we implemented this on SQL Server, MongoDB, and SQLite for every resource in a data model that will support any type of resource, including custom ones. But you can implement this for your data structures. And that's what a facade is in Vonk. My pen died. Why is that? Whatever. So what can you use it for? You could, for instance, if you have a CDR, we have hospitals here in the Netherlands that do this, they gather all this data together on the database level, because that is much faster than through a RESTful API, of course. Put it in one large database and then open it up through FHIR. So they open up their clinical data repository with the facade. You could, maybe your EHR doesn't provide a FHIR interface, but you do have access to their APIs or their data, and then you can put a facade on it for the pieces that you need. Maybe you have a document store that you want to provide access to, that you can program it on top of. Then departmental systems across your hospital or other organizations, every department has its own system, and you need to learn the API or the data access for every system to gather data, to make an app on it. You could provide every system with a small Vonk facade for only those resources that are in there, and then have a common API to access them. You can also program against other APIs, of course. Slightly more detailed on the previous schema. What you see here is we also have a administration endpoint where you master all the metadata, so the structure, definition, search parameters that we understand. It's the same pipeline, but the pipeline you're concerned with is this one. And that's where the FHIR REST calls go in. So you see the components that we already provided. An HTTP interpreter will transfer from an HTTP request to something that's more FHIR-like, what we call the Vonk context. Transaction will interpret all the transactions and make all the other parts run in a transaction. And then we have one for search, for create, for conditional, create, etc., etc. Now here's SQLite under it, which is the default database when you download it, because it's pre-created for you and it just runs. Now you can change this to SQL Server. This is a configuration change. Plus you need, of course, a database server to actually host the database, but it's that simple. And this too. And now for a facade, you switch this out for your own database, or your own web API and your own implementation. So, or another API. Even other FHIR APIs. Dealing with multiple versions. You just built your version 3 API and then, bam, R4. Well, make another API, make another facade and turn it into R4. A facade is technically in the framework also a plugin, just like other plugins. For those who have seen the plugin session on Wednesday. And the only thing is it just doesn't put a component here in the pipeline, it just provides services to the system. Services that implement that search repository in the resource change repository. Why is this called resource change repository, not change repository? Don't ask me, that's history. But since it's public, we can change it. So what are the advantages? Oh, that's slightly too fast. Oh. Thank you. What are the advantages? You can utilize the full Vonk server setup, including flexible app settings that can be overridden in subsequent settings files, logging, all the dependency injection going on. You can connect application insights to it, which is something on Azure to see what happens, or other things that could monitor your application. And you focus on your logic. You know your data model, your business model, and you provide the data access to it. You can also use the administration API to manage the search parameters, the structure definitions, validation, code system value sets, etc. It's all in there. You don't have to provide that. Now, what's going on inside in that pipeline? By the way, if you have questions, don't hesitate to ask. What's going on inside that pipeline? As I said, we interpret the HTTP context into a Vonk context that expresses the interaction that you're running. So is it a create, is it a search, is it a conditional update? It has any payload that comes within it, like in the form of a resource. And it has all kinds of arguments in the case of a search, for example. And that's going in here in that pipeline. Now, this pipeline in itself are usually just thin layers around calling the actual services doing the work. So there is a create service and there is a search service. And they're doing the actual work, and this is just to make it fit in the ASP.NET Core pipeline. They are talking to these interfaces that I just described, the search interface and the write interface, and then there is the data. Yes.
How do you handle custom operations if you want, for instance, a report?
Yeah, you would write a true plugin. You don't need a Facade for that, unless you want to run it on your Facade, of course. You can have a Facade and a plugin, whatever you like. You can host 10 plugins if you want. Yeah. So you get a bit of Vonk and a touch of your own, because this is what you get and this is what you built. And this is what you already have. So it's the middle piece here. We chose programming over configuration. That's because in programming you have a maximum flexibility. Of course, you can map anything anywhere. It's fast because it's compiled. And what we do while doing this is we collect common patterns for people making these facades to see whether we can provide base classes to make that easier. Over time, we will probably provide other methods as well. We just released the FHIR mapper, which is the mapping engine in Vonk. That's also very interesting, of course. If you can express your source structures as structure definitions, then you can use the FHIR mapper to map to and from them. So it's a growth model. Over time, there will be more ways to actually map your data. But so far, nothing beats just building a simple POCO and feeding your data into it. There's a GitHub repository with Vonk Facade Starter, which is a project that simply builds a facade on an existing relational database with only a couple of tables and only 2 types of resources. So that's it. We put Vonk as a facade on that database. We're going to run through that. First, you need Vonk. You can download it from Simplifier. This link is also in the bit.ly link I told you earlier. And you just need to log into Simplifier. Well, you want a Simplifier account anyway if you're here. And you get a fully functional free evaluation license that is valid for a month, and you can get another one if it expires. You can download the Docker image, but to experiment with plugins, you want the binaries. That's the zip file you can download. Now, what does a facade look like? It's a simple library project. It's a net standard 2 library project in .NET. There's nothing special to that. The only thing you need is a couple of packages that Vonk provides. In this case, we do Vonk Core and Vonk Facade Relational, which is an example of base classes we provide to make it easier to access in a relational database. And we use for STU3. there's a Vonk FHIR R4 as well. It is possible to make a mapping that fits both models, but that's slightly more involved. I will not go there in this presentation. There's an example database. It defines a patient and a blood pressure table. And we have the acronym VISI for vital signs for this example. And of course, there's this correlation between the tables and the resources. First you need to do is access that database. You need a DB context for that. This is just that .NET Core work. You can write it by hand, or you can reverse engineer it from the model in your database. There's not much special to this. The interesting thing is you need settings to access the database, more specifically a connection string, and you can just use the Vonk settings for that and access them from there. Then you need to implement that search repository. Searching is one of the hardest things to do in FHIR. Well, not to do, but to implement. Because it has many, many different search parameters with many different modifiers, and you can combine them in change searches, reverse change searches, includes, ref includes, the whole shebang. We're going to help you in doing that search on your database. And that's why you implement this search repository. The query context is going to help you break down the search that comes in on the request to individual pieces that you can then map to fields on your database. So we start with the arguments that you saw coming in here on the search. This is the main and only method of the search repository, so that's quite clear. Actually, this is derived from the Vonk Facade relational, where we already arranged for you that there will be searched for only one resource type, because in Vonk itself we can search across resource types. We imagine that's usually not the case. So you get one resource type that's being searched on, the arguments that are being searched on, and a couple of options. So you get the raw arguments, and if you want to, you can process them yourselves. They look very much like exactly on the query string. But usually you would not want to do that. So, building queries. The search service issues a search with these arguments. And then there's a query builder and a query context that can tear this all down into several pieces, and you have to provide the middle piece. So what happens here, I'm going to walk through it. You do a search and you say, create a query for me. I'll give you a query factory. That's something you implement because you know what type of query you want to create. Do you want to create a SQL query? Maybe in a specific type of SQL because you want to use specific functions in Postgres or whatever. Or Mongo query, or do you want to create another query URL because you're addressing another web API? We cannot know, so you get to define your query factory. And the query it produces, of course. So you hand that over to the query context. That then creates a query builder that says, build this query with these arguments. And the query builder for Q. Q is the type of query you are building. So it's maybe a query string, it may be a link expression, it may be other types. And this breaks it down into the individual pieces, and then for every parameter you get a filter call. This filter call tells you which parameter is being searched on. For example, if I start with patient.name is Fred. Yeah. This will be name, and this will be a string value because Fred is a string search parameter. And it also tells you whether it was an exact search or not. On the other hand, if you do a observation value is 3 milligrams, that's a quantity, which is much more complicated than a string. You will get a quantity value, including a canonicalized quantity based on the UCOM standard. So if it was being stated in milligrams, it will come in grams. I think that's the standard unit. So that's all being done for you, and if there are search parameters not being supported in your by definition, then they are rejected before you even get to them. If there's modifiers that are not valid, they're being rejected. If there's a change search, it's being broken down. You don't see that. You first get the one on the referenced one, etc. We're going to see an example of that. Now you get to the query factory that you define. You say, oh, I know where patient name is. It's a simple query. It's my patient table, and you have to choose first name, last name, both. I provide a predicate on that, a where clause, and hand that back. And then you get and or combinations. The or is just for choice types, so when there is a value on the search string with commas, you cannot do or on just any level. That's the only level you can do it. And then the rest is ANDed together. So if you build a query string, you put a ampersand between it. If you build a predicate, you do a proper AND, etc. Now, when that's all ready, then this has the complete query ANDed together. And it says to the repository, well, execute that query in your context. In this case, it's a DB context. Maybe it's a web API that you issue it to. You get a result, of course, hopefully. And there's one thing to do, it's map the FHIR resources. So there's two major steps. One is translating the query to whatever is your backend. And that's what the query factory is for, and it gets piecemeal pieces of the query to translate. Then there's the other way, you get results from your database, you need to map them to FHIR resources. So that's the part you define. All the rest is already there. So Vonk finds out what to query for, what kind of search parameter it is, and you control how you query. Again, the query class can be anything that holds information for a query. We don't force you into any query class. For here, we're going to define a patient query and a blood pressure query, because you want to be able to combine that, and it's on a single table. You can create multiple query types as well, as long as you give the right factory. Then Vonk Facade Relational, we have a couple of base classes to make this a little easier if you use Entity Framework Core and Link on a relational database, which we think is a rather common case. Back to that search method. As I said, iSearch repository has a search which has just arguments and options. The relational abstraction tears it down if there's multiple resource types. We will reject it. And for you, you just check the resource type, create an appropriate query factory for it. So now we're going more into the example where we actually query a relational database with these tables. So you create an appropriate query factory. Could be different per resource type. Maybe half of your resources type is in system A and the other half is in system B. You call that query context, create the query, execute that query, map the data to the resources, and then assemble them in a search result. To that query factory, values correlate to search parameter types. These are the search parameter types. There's a resource types value, which gives you a couple of resource types. There's a string value for name, for example, datetime value, token value. If you're familiar with the FHIR search interface, this will look rather familiar to you. The special ones are a reference to and from, which correlate to change searches and reverse change searches. So that's where you need to define what to join with. And that's raw value. You can use a search parameter that's not even known to Vonk. And then you will get your hands on it to handle it if you want to. But we don't know what it is, so we can tell you any type of value. I recommend to make the search parameter known to Vonk with a proper search parameter resource. Now there's reference filters. You need to create so now we're gonna walk into observation subject is, or observation subject name is Fred. Does everyone know that type of search in FHIR? So then first you get a query for patient name. We already did that. You create a patient query factory, name, and no name. Now then you get one on observation that says now query for subject. You get the chance to provide another query factory that says, okay, go on with this one and build a query on patient, because I know subject refers to my patient table and I want a patient query on that. And then afterwards it will be joined by when the query is executed. So what we wanted to avoid is that you need to fetch the results first and then put that in a second query. This way you can build an efficient join that is executed at once in the database. If joins are impossible in your database, if you're running Mongo, for example, then you still need to do a sub search, get the results, and put them in the next query. Before we go into this, I want to quickly show you where we are going. So this is the actual project. We see it here. If you download it, Vonk Facade Starter. Here is another way of implementing this than a plugin. That's an old way. I do not recommend to start with that right away or ever again. It's for history reference. And we see all these classes that I'm discussing here. We see a query factory for the patient, one for the blood pressure. We see a resource mapper that contains the mapping from the data to the resources. We see the search repository. There's a change repository as well, and we see some configuration. The interesting thing is, and of course the DB context is somewhere here. Oh, it's in models, I think. Yeah, here's the VC context, that's the DB context, and there's the entity framework objects behind it. Well, this is all there is for this facade. Show you some real code. Here is that actual search repository. There is a special attribute here that says this only works for FHIR3. And here is that search method. I say, if I have patient, I said search patient, and that effectively provides a patient query factory and go search on that. Or we search for observation, and if anything else is there we don't know about, not implemented. Yeah, so you can see a bit where we are going. Nice example maybe is when we run Vonk. Maybe it is running currently. Let's see. No, it's not running. As you can see here, these are the app settings for Vonk. It's not all of them. I extracted a little, the essential parts of it. And, well, there's not much to it. Okay, yeah. You see here, normally it runs on SQLite by default, but the only thing I need to do when I provide the plugin to the plugins directory is change this, and now it will run on my database. For sake of time, I will not run it right now, because that will take a little time to start in debug mode. Instead, I will move on to one of the more complex searches that you need to do. It's what I just tried to explain already in by telling you it's here in code. So observation subject, it's narrowed down to patient, because subject can be three other types as well. Name is John. And what we do here is, we check whether we know this parameter name. So we say add value filter for a reference to filter value. This add value filter is not in the is something we provide in the Facade relational abstraction. So you say it's a subject, and does it indeed target patient? Because if it targets group, we don't know about it, so we don't handle it. Then we create that patient query. It's another query with, oh, don't do that, with a patient query factory on my same DB context. And now I say, get me the IDs of that, and this has to contain that ID. It looks like things are being executed here. Effectively, it builds a whole expression tree that's being translated to a single query. So that's how this works. And for the other query, you end up in your own query factory again, and that will be built. Of course, you don't know all the arguments. If you don't know it, just ignore it. And Vonk will say, this argument was not supported, because in a FHIR search, you're allowed to skip arguments as long as you report it in the output. If it contains an error, you can do an argument exception, and it will also end up in the operation outcome. And if for some reason internally you say, oh, this argument must be handled, otherwise there's really an error, it cannot be skipped, you can send must handle to true. And if it's then not being handled by your Facade, it will not respond with a search result, but only with an operation outcome stating that an argument wasn't handled that should be handled. Then the other way around, you get data from your database. It's as simple as create a new patient in the .NET FHIR API. Patient is new patient, and then fill in its properties from the set that you got from the database. You assemble it into a search result, which next to the resources itself gets the page size, so how many resources did you return, and how many are there in total. And Vonk will then turn it into a proper bundle to return, either in JSON or XML. You don't need to do anything for that. Configuration, you just saw me configuring the VC repository instead of the SQLite repository, so that's easy. Dependency injection, I'm going to skip a little of that, I guess, based on the time. This is something, it's just ASP.NET Core, so you can read that elsewhere. But for you to know is that you need to register your DB context. It has to be request scoped. You have to register your search repository, and since it uses this, it's also request scoped, your change repository, and your resource mapper. So they can be injected into, for example, the create service. And this is how you do that. This is how it's being done in a plugin. It says Vonk configuration. That will make Vonk recognize it as a plugin. And you said add my services to the service collection. And you can also have the configuration injected, which is interesting for your DB options. Well, this is just normal ASP.NET Core. The only thing special is try at context aware, which acts on that attribute you saw before. This only works for R3 and not for R4. It's also in the documentation, of course. Oh yeah, one thing always you try at, because it might get called multiple times because of the way we configure Vonk. You don't want to register it multiple times. App settings, I just showed you this in real life. You just make sure that your Facade DLLs are in the plugins folder. It may also be a subfolder. You remove the default DB registrations and you add your own. And you limit it to the operations you want to support, because normally Vonk supports well everything. And maybe your, for instance, if you only implement the search repository, you cannot do the create, update, and delete operations, of course. And you can just leave them out of the operations and it will not even try to execute it. If you have limited support, like for 2 resource types, a couple of search parameters, you can say that in your app settings as well. 5 minutes to go. And there's create, update, delete. So if you want to do the changes, you have to implement iResource change repository. And then you have to provide the mapping back. So you get an iResource, which is the Vonk abstraction of all the types of resources in different versions of FHIR. And you have to map that to the data that goes into your database. Save the changes, map the results back. Maybe your database changed something in a trigger or whatever, so you map the results back because the create and the update operations can return the created or updated resource. And Vonk provides pre-validation. Vonk provides a full validation engine, of course, to validate against profiles, against the core spec. And you can create a profile, feed it to Vonk that states exactly what you understand. And then the pre-validation in Vonk can say, I don't accept this because it doesn't honor the profile that I do support. And then it will never end up in your repository anyway. So that saves you a lot of trouble. Just explain it, and you can put that on Simplifier for anyone to review. If you send something to me, it has to be this profile. There's a whole list of classes to work with, and we put them in the Vonk reference documentation on docs.simplifier.net/Vonk. Reuse, that's the interesting part. Because now I have search and maybe create, update, delete, and now it can take part. The search also provides the read, because that's reading for a single instance, searching for a single instance. It also provides version read, if you have versions, of course. It can also help in history. That also goes over the search interface. You can also do it in transactions. And maybe on the next slide, maybe on this one, no, not even. But the include and the ref include are handled for you as well, as long as you have support for the search parameters used in that. So if I say observation includes subject, and you implement subject, you don't have to do anything special for include, it will work. You just get a second query to do that include on your observation subject that you already implemented. Same for ref include. Don't have to do that yourself. Change, it supports all the create, update, delete, also the conditional, but then you need it in conjunction with the search repository, because conditionals have to search whether it's already there. And it also works in transactions. You don't have to provide the transaction support, we do that. Yeah, I think this is a bit too much for now. So I'll explain you where the exercise is. On the same link again. So you have to arrange the prerequisites. You can do that in the break or have a coffee. And clone that project. And then this is what we're going to do later. You can make it run inside your own Vonk instance. Except Vonk Facade starter. So you get to all the nitty-gritty details and configuration stuff that why does this not work. But this time I'm here to tell you why it doesn't work. And then you can start expanding the facade by searching on patient name, because that's not in there yet. So that's for the next session. Any questions for the final minute?
How can you support transactions? Do you need to also have a rollback feature in your facade, in your implementation, to allow it to be able to roll back if the transaction fails?
Yes, if you actually want to do that, there is a transaction service that starts the transaction, and you will have to start implement that to start the transaction on your DB context, and then the rest runs in that transaction, and will be rolled back accordingly if necessary. Yes. Oh, there's 1 more minute, so we can do another question if you want.
Christiaan, a facade server normally would have the master data in the legacy system. Is that correct?
What is?
Do you have an extra repository of data storage inside the Vonk server as well?
Oh, you mean for the administration API?
I mean basically for the master data.
Yeah, the unit structure definition, search parameter, etc., or other master data.
You have when you have a write into the system.
Yes.
Update, right?
Yeah.
Then the legacy system will eventually be written.
Mm-hmm.
Does it also store inside the Vonk server so we have a multiple master?
No.
Okay.
Because maybe that's a bit clear if we see it here. I take out the normal storage and I put in my own storage.
Can you use both?
No.
Okay. So that's okay. Thank you.
One or the other. Other questions? No. Then feel free to stay for the hands-on or have coffee first or go to another session if you're interested.